Hey, let's begin with Mendeleev's periodic table. While working on the classification of elements, a Russian scientist Mendeleev found that when elements are arranged in the order of increasing atomic masses, the elements with similar properties occur at regular intervals. Based on this observation, Mendeleev gave a periodic law in 1869. According to Mendeleev's periodic law, the properties of elements are a periodic function of their atomic masses. Mendeleev's periodic law means that if elements are arranged in the order of increasing atomic masses, then the properties of elements are repeated after regular intervals or periods. So, in his periodic law, Mendeleev arranged all the known 63 elements in the order of increasing atomic masses in horizontal rows, but in such a way that elements having similar properties came directly under one another in the same vertical column or group. So the similar properties used by Mendeleev to classify elements into groups were the similar formulae of the oxides and hydrides. So a part of Mendeleev's periodic table is shown here. There were 7 periods and 8 groups in the original periodic table of Mendeleev. So out of 8 groups, first 7 groups are of normal elements and 8th group is of transition elements. Noble gases were not known at that time, so there was no group of noble gases in Mendeleev's periodic table. So the elements in each group of the periodic table are similar to one another in many properties. The similar properties of the element are repeated periodically. We will now describe 2 main features of Mendeleev's periodic classification. One is increasing atomic masses and second one is grouping together of elements having similar properties. In order to make sure that elements having similar properties fell in the same vertical column or group, Mendeleev left some gaps in his periodic table. These gaps was left for the elements not known at that time. Mendeleev thought that these elements would be discovered later on and even predicted the properties of these elements by studying the properties of the neighboring elements. The missing elements of Mendeleev's periodic table was discovered later on and their properties were found to be very close to those predicted by the Mendeleev. The undiscovered elements at that time for which gaps were left in the periodic table were named by Mendeleev as Eka boron, Eka aluminium and Eka silicon by prefixing the term Eka to the name of the preceding element in the same group. The term Eka is derived from Sanskrit, which means first. So Eka boron means first come boron and then the unknown element. When these elements were discovered later on, Eka boron was named as the scandium and Eka aluminium was named as the gallium and Eka silicon was named as the germanium. Again, in order to make sure that the elements having similar properties fell in the same vertical column or group, Mendeleev placed a few elements in the wrong order of their atomic masses by keeping the elements with higher atomic masses first and the elements with lower atomic masses later. For example, Mendeleev placed cobalt having higher atomic masses of 58.9 before nickel having lower atomic masses of 58.7, so that cobalt could be in the same column as rhodium, which closely resembles the properties of the cobalt. So that's the overview of the Mendeleev's periodic table, and now let's discuss the Mendeleev's periodic classification of elements. So Mendeleev's periodic table was of great help in the study of elements and their compounds. So let's discuss them. Mendeleev's periodic law predicted the existence of some elements that had not been discovered at that time. In fact, Mendeleev's periodic table left proper gaps for those undiscovered elements like gallium, germanium, and scandium. When these elements were discovered later on, they were placed in those gaps without disturbing the existing elements. Now let's discuss the second one. Mendeleev's periodic table could predict the properties of the elements on the basis of their position in the periodic table. We can see from the above table that the properties of Eka aluminium predicted by Mendeleev are almost exactly the same as the actual properties of the gallium element. So that's the idea about the second one, and now let's discuss the final one. Mendeleev's periodic table could accommodate noble gases when they were discovered. So When a new group of elements called noble gases was discovered, it got a place in the periodic table in the form of a separate group. It did not disturb the original arrangement of Mendeleev's periodic table. The noble gases are placed in a separate group because they are unreactive and present in extremely low concentration in the atmosphere. So that's the idea about the merits of the Mendeleev's periodic table, but a few limitations could not be explained on the basis of the Mendeleev's periodic law. The position of isotopes could not be explained on the basis of Mendeleev's periodic law. Isotopes are the atoms of the same elements having similar chemical properties but different atomic masses. So the isotopes were not given a separate position in the Mendeleev's periodic table. For example, the elements of the chlorine has two isotopes, Cl35 and Cl37, having atomic masses of 35 and 37 respectively. The placing of these two isotopes of chlorine having different atomic masses in the same group of the periodic table could not be explained by Mendeleev's periodic law. That's about the first limitation, and now let's discuss the second one. Wrong order of atomic masses of some elements could not be explained. According to Mendeleev's periodic law, the elements are arranged in the order of increasing atomic masses. So the element with low atomic masses should come first and the element with high atomic masses should come later. When certain elements were put in their correct order on the basis of their chemical properties, it was found that the elements with high atomic masses come first and the elements with lower atomic masses come later. For example, when we put in the correct order of the basis of the chemical properties, the elements cobalt having high atomic masses of 58.9 comes first, and the nickel having slightly lower atomic masses of 58.7 comes later. Mendeleev's periodic law could not be explained this abnormal situation of wrong order of atomic masses. So that's the idea about the second limitations, and now let's get the third one. The position of hydrogen could not be assigned in the periodic table. In Mendeleev's periodic table, the hydrogen has been placed in group 1 with alkali metals. This is because, like alkali metals, hydrogen also combines with halogens, oxygen and sulfur to form compounds having similar formulae as shown in the following table. This means that the hydrogen also resembles the alkali metals in the sum of the properties. Hydrogen also resembles halogens like fluorine, chlorine and bromine in some of the properties. For example, just like halogens F2, Cl2 and Br2, hydrogen also exists in the form of diatomic molecules. However, just like halogens, hydrogen combines with certain metals to form ionic compounds called hydrides and reacts with non-metals to form covalent compounds. All these properties show that hydrogen could be placed in the group 7 or halogen elements. From the whole discussion, we conclude that on the basis of its properties, hydrogen element could be placed in alkali metal group as well as in the halogen group. Thus, Mendeleev's periodic law could not assign the correct position to hydrogen in the periodic table. The failure of Mendeleev's periodic law to explain the position of isotopes, wrong order of atomic masses of some elements, and position of hydrogen suggests that the atomic mass cannot be the basis for the classification of elements. It was thought that there must be more fundamental properties of elements which could give a better explanation for the periodicity in the properties of elements. This property was found to be atomic number of the elements. We will discuss the next modern periodic law in the next lecture, where we discuss about the atomic number. So that's the idea about today's lecture. I hope you enjoy my lecture. See you in the next video.